number system, irrational numbers. At the end of this lesson, you will be able to define an irrational number, and locate irrational numbers on the number line. Introduction to irrational numbers. It is a Monday morning, and the first period is maths. The maths teacher asks the students to represent the numbers 2, 2 by 3, 4, and -5 on the number line. All the students did it right. They represented 2, 2 by 3, 4, and -5 on the number line as shown on the screen. The teacher now wanted to start with the next topic, irrational numbers. Judith is a studious girl who loves maths. Judith asks the teacher if she can plot the square root of 2 on the number line. The teacher decides to teach the students about locating numbers like the square root of 2 that are irrational in nature. Join with the maths teacher as she teaches about representing irrational numbers on the number line.
Recall that a number r is called a rational number if it can be written in the form p by q, where p and q are integers, and q is not equal to 0. Similarly, a number s is called irrational if it cannot be written in the form p by q, where p and q are integers, and q is not equal to 0. Some examples of irrational numbers are displayed on the screen. When we use the symbol square root, we assume that it is the positive square root of the number. Irrational numbers are denoted by the symbol p. As there are infinitely many rational numbers, there are infinitely many irrational numbers too. The collection of all rational numbers and irrational numbers together make up what we call the collection of real numbers, which is denoted by r. Therefore, a real number is either rational or irrational. Thus, every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. Hence, we call the number line the real number line. Let us now see how we can locate some of the irrational numbers on the number line. Consider the irrational number square root of 2. Solution: consider a square, OABC, with each side of length 1 unit. Triangle OAB is a right-angled triangle. By the Pythagoras theorem, OB equals root of 1 square plus 1 square, that equals the square root of 2. Transfer the figure onto the number line, making sure that the vertex, O, coincides with 0. Using a compass with center O, and radius OB, draw an arc intersecting the number line at point P. Then point P corresponds to root 2 on the number line. It's easy, right? Next, let us try to locate the number root 3. Consider the figure that you obtained on locating root 2. Construct BD of unit length perpendicular to OB. Then using the Pythagoras theorem, OD equals the square root of root 2 square plus 1 square, which equals root 3. Using a compass with center O, and radius OD, draw an arc that intersects the number line at point Q. Then Q corresponds to root 3. Thus, we have located root 3, after locating root 2. In this way, for any positive integer n, you can locate root n, after locating root n minus 1. We shall now solve a few problems. Problems on irrational numbers. Represent root 5 on the number line. Construct a number line. Consider OA to be of 2 cm, and AB to be of 1 cm. Using Pythagoras theorem, the length of OB equals the square root of OA square, plus AB square. Substituting the values of OA and OB, we have OB equals root 5. Using a compass with center O, and radius OB, draw an arc that intersects the number line at point P. Then point P corresponds to root 5. Can you now try drawing the square root of numbers from 2 to 17? Mark as center point O. From point O, draw a horizontal line of length 1 cm. Mark the end point as Y. From point Y, draw a perpendicular line, YB of length 1 cm. Join OB here. OB equals square root of 2. Now, from point B, draw a line perpendicular to OB of length 1 cm. Mark the end point as C. Join OC, here, OC equals root 3. Repeat steps 4, 5 and 6, to get the drawing of root 4, root 5, and so on, till root 17. We have thus obtained a square root spiral. Hope this makes you clear about locating irrational numbers on the number line.
Conclusion. We know that 1 by 2 equals 0.5, 2 by 3 equals 0.67 approximately. So, what could be the decimal expansion of root 2? Can we use decimal expansions to distinguish between rationals and irrationals? We shall see that in detail in the upcoming lesson, terminating and repeating decimals. Until then, bye. Let's now summarize what we have learnt in this lesson. A number is called irrational if it cannot be written in the form p by q, where p and q are integers, and q is not equal to 0. The collection of all rational numbers and irrational numbers together makes up what we call the collection of real numbers, which is denoted by r. Thus, every real number is represented by a unique point on the number line.